This is Dr. John, and this week we will be working on week 4 homework answers. That's chapter 11, and chapter 11 is fluid statics. And quite honestly, I think this is one of the one of the easier weeks in our study. Hope you agree with that. So let's get started with problem number 2 is the first homework problem we have to. Problem number 2 states the following. Mercury is commonly supplied in flasks containing 34.5 kilograms, about 76 pounds. What is the volume in liters of this much mercury? Okay, so the mass of the mercury is 34.5 kilograms. And looking in table 11.1 in the chapter, you see that the density of mercury is 13.6 grams per cubic centimeter or per milliliter. The cubic centimeters and milliliters are the same in terms of volume. And so if we say we have 34.5 kilograms of mercury, and the density of mercury, or first of all, let's change that to grams. So that's 1,000 grams per kilogram. The density of mercury is 13.6 grams per cubic centimeter. And if we look at 1,000 cubic centimeters in a liter, it says that wants the answer in liters, so that's 1,000 cubic centimeters or 1,000 milliliters in 1 liter. Now this 1,000 cancels this 1,000, and so if you divide 13.6 into 34.5, it'll give you the answer, which is 2.54 liters of mercury. Number 7 is the next problem. A trash compactor can reduce the volume of the contents by 0.350. So V1, if V1 represents the volume before you compact it, then V2 is going to equal 0.350 V1. And the question is, what is the change in density when you do this operation, or what is the ratio of the density? Well, if the first density, D1, is equal to the mass divided by V1, and the second density is equal to the mass divided by V2, which is equal to the mass divided by 0.350 V1, then what you know is if you take D1 divided by D2, that's going to equal mv over V1 divided by m over 0.35 V1, which is going to, after you cancel everything out, you have 1 over 0.350, and 1 over 0.350 is 2.9. So that means that the new density is 2.9 times what the density was before it was compacted. Problem number 9 states the following. What is the density of 18 karat gold if it's made up of 18 parts of gold, 5 parts silver, and 1 part copper? Now the first thing I did was change this. If you look at this, there's 24 total parts. And so the percentage of gold is going to be 18 over 24 times 100, which is 0.75 times 100 would be 75%. The percent silver is 5 over 24, which is 0.208 or 20.8%. And the copper is 1 over 24, which is equal to 0.0402, or 4.02%. Now, the way you do this is exactly the same as when in chemistry we calculated the weight of an element given a certain percentage of each isotope. You do a weighted average. And so if you take 0.75 times the density of gold, which is 19.52, plus the amount of silver, 2.08, times the density of silver, and I actually had to look this up online. It was not in the table. It's 10.5 plus 0.0402 times the density of copper, which is in the table, and that's 8.8. If you do the math here, you end up with a density of 17.0436, which is 17.0 grams per centimeter cubed. The next problem is problem number 22, and now we're moving from the density problems into pressure measurement problems. And this first problem states the following. The left side of the heart generates enough pressure to give a blood pressure or a pressure reading of 120 millimeters of mercury. And it says that the area that pressure is exerted on is approximately 15 square centimeters. It's asking what is the force given that area. This is pressure. And what is the force? Now we know that force is equal to pressure times the area. So we're going to have to state this pressure in a units that can work with this. Now area, if this is the effective area, you can change this to meters squared, because if you look in table 11.2, you'll see that most of the pressures are not expressed per square centimeter. Well, so I changed this to square meters, and if you do that, you get 0.015. If you divide it by, two zeros here. If you divide it by 100, then divide it by 100 again, it's this area is equal to 0.0015 meters squared, or 1.5 times 10 to the minus 3 meters squared. And if you look at that table 11.2, you'll see that pressure of 120 is 1 millimeter of mercury is the same as 133 newtons per square meter. So if you multiply 133 by 120, you get 1.6 times 10 to the fourth newtons per meter squared. And if you multiply that by your area, consistent with this formula, 1.5 times 10 to the minus 3, you get a value of 24 newtons as the effective force in the heart to generate this pressure. Number 25 is the next problem. Number 25 states the following. And now we're into Pascal's principle, which is, the principle basically states that a force exerted on a closed container of liquid is transmitted equally throughout the entirety of the liquid. And this is the principle that is used to make hydraulic or liquid-filled machines called hydraulic lifts or hydraulic machines. And so the first problem says, what force must be exerted on the master cylinder of a hydraulic lift to support the weight of a 2,000 kilogram car resting on a slave cylinder? Now, just to give you an idea of what these terms mean, in case you don't know, the master cylinder is the small cylinder that you exert your pressure on, or your force on, and the slave is the one that responds. And so the car is on the slave cylinder, and the master cylinder is over here. So the force on the master divided by the area of the master is equal to the force on the slave divided by the area of the slave. Now in this case, the force on the master we don't know. The area, it tells us that the master cylinder has a diameter of 2 centimeters, so that's a radius of 1 centimeter. So the area is going to be pi times 1 squared. And this is going to equal the force of the car, which is 2,000 kilograms times 9.8, divided by the area, which is going to be pi times, and that diameter, the slave diameter, is 24, which is 12 radius squared. So if we put the numbers in here, we have F in the master cylinder divided by 3.14159 is equal to 2,000 times 9.8 divided by, this is 452. So that means that FM, if we cross multiply, you're going to have 2,000 times 9.8 times 3.14159, which is pi, and then all of that's going to be divided by 452. So the force on the master cylinder is going to end up being rounded off to two significant figures as 140 newtons. So it takes 140 newtons, or the equivalent of, say, approximately 15 kilograms, to lift this 2,000 meter car, or 2,000 kilogram car. Number 27. Number 27 states, a certain hydraulic system is designed to exert a force of 100 times as large as one puts on it. So the force on the master related to the force on the slave is 1 to 100. So that means 100, that the force on the slave is going to equal 100 times the force on the master. So whatever you put on the master, if you want to know what the slave is, you have to multiply by 100. So the first question is, what must the ratio of the areas of the slave and the master cylinder be? So it's asking if Fs over Fm is equal 100, then what is As over Am? And as you know from looking in the book, they're the same. So this is also going to equal 100. The second question is, what is the relationship of their diameters? Well, we know that the area is going to equal to pi r of the slave squared divided by pi r of the master squared. And we know that pi and r is d over 2 squared, and pi d over 2 squared. And so this is slave and this is master. And so these two cancel out, and you end up that after all the math is done, it's going to be ds over d master, and each of these are going to be squared, is equal to 100. And so that means the ratio is going to be equal to the square root of 100, or 10 to 1. So the ratio of the diameters is the square root of 100, or 10 to 1. The third question is, by what factor is the distance through which the input force moves? Now, the ratio of the areas is actually inverse the ratio of the distance. In other words, you know that work has to be conserved. So that means that the force times the distance of the slave has to equal the force of the master times the distance of the master. And so if the slave is 100 times the master, you can fill out the form like that. Then if you want to know what ds over dm is, it's going to be Fm 100 Fs. So it's 1 to 100. And that means that the master moves 100 times more than the slave does whenever you're lifting. I should have wrote this down. Okay, so that's problem number 27. Let's stop this recording at this point